Good afternoon. It is 1 in the afternoon. It is Thursday. So I guess I'll actually have to get back to work, something like that, right? So yesterday I was working on the dynamic waves, writing to a texture, rendering out that texture in debug mode. We got our waves actually working. We got them working in shipping mode. Did all that stuff. So we've got all that going on there. And what we need to do is we need to actually have these waves be affected by the motion of the water that they're on. So each one of these particles, we're going to need to add some sort of lookup into this texture. So I need to come up with a small list of tasks. So I want ripples to be affected by the flow field. I want to then actually make the graphics effects for these things. So we'll switch over to actually messing around with the water material itself after this. So let's get this rolling along. Alright, so when we update these ripples, we're going to find our normal, do all that, but we need to affect our velocity, our direction, that is, by what we're on. So what we have to do is we want to look at the location where we are. We want to get the actual flow field data at that location. So we're going to need to crack open that flow field texture and get the values out of it. So we have the distance texture, but we're going to need our flow field data as well. And we're going to need to crack it open just like we cracked open the distances. Yeah, it's going to be this actual flow field. Alright, so what I'm going to do is I'm going to make a function in our graphics utils that will open up a texture and read it into an F-color T-array for us. So let's get started on that. Because if I'm doing it once or twice, I probably need to just write something that helps me do that. Let's see, load. Let's actually have a Boolean for if it's successful. Let's say load texture into color array. So we're going to take a U texture 2D star the texture, and we're also going to take a T array of F color reference colors. Alright, so we got our update texture regions, and we'll get our load texture into color array. Maybe I should spell array properly. Spelling's overrated though. So what do we need to do? I need to figure out what the size is of a texture. So does the texture actually have that information on it? So uTexture2D has got address X, address Y. We've got platform data. We have size X and size Y on the platform data, which is right here. Alright, so there's our SX and SY. So we got our width and our height. We'll initialize it. We should probably pass in an initial color, so we'll have like f color at const f color address initial color. Alright, so we'll have success equals false. We're going to return success. We don't want to return something else. We might skip that unlock. So this should read everything properly. And we will be able to get our color. Call this to load our texture into a color array. For this to work, you must have an sRGB texture with no bitmaps specified. That is just reality. Alright, so we should be able to actually call this thing and start using it. Alright, so the texture is going to be full field texture. And I guess we will initialize our full field texture. What do we need? Probably black or something like that is our... Actually, how about the magnitude is supposed to be written in there, so we'll have like a red color, so it's 1 in the X, but not have much going on with it. Alright, so that should do that. Let's make sure I didn't screw something up compiling. All the work you're doing with water makes you question your existence. Hello, Terrific Taylor / the former CC. Yeah. Well, hopefully, actually, the water stuff will be done here this week. Once I get the dynamic water ripples set up, I mean, it's really just... I don't really see much else that we'll need. Like, we need decal systems and all that for stuff, but that's not necessarily water. That's more of a weather effect. You know, we need a weather effect for raindrops and crap like that, and we'll have different ones for different things. But that's more of a decal system, not necessarily water. So it's almost done. And one of the other things we're getting done here is instead of using these, like we're saving these UAsset files for our content, for our levels, for our water, and these like 4 meg files are these like distances. If we're saving like f-color height map data and stuff like that, it's actually pretty big on disk and pretty wasteful. So I'm switching it over to using the textures to store the actual raw data, which should really make things work better. So we can use all the systems that we're supposed to be able to use. Theoretically, I can just do this. It's not the flow field texture, it's the distance texture. Alright, well let's go hook up our setup basic map info with our flow field texture information and get that rolling properly in our blueprint. There's quite a bit of cleanup work I need to do for the whole water system once I get it finished. But it doesn't need to all be solved right now. Alright, so it's the actual flow field texture. So I'm actually going to look this one up real quick. Check out its MIP settings. MIP settings is from texture group. We need to not do that. We need, when we create this flow field texture, to actually set it to no MIPS. This is the distance, this is the height map, this is the flow field. So I need to regenerate this texture. That's what it looks like. So I'll have to do the whole tick and generate step, which is going to take just a little bit. 9 files need to be checked out. Well, let's check them out. Alright, it now says MIP settings of nothing. Excellent. Very good. Alright, so the next step is going to be... So we got these things working properly. We need to get these things actually to be affected by the flow field. So we have the actual flow field information. So the question would be, what should we actually do with the flow field? I think we will, we could take the current direction So how should we apply the flow field to this stuff? We can look at where we are and just be like, well, we should go in that direction as well as our previous direction. If we added... If we added our direction and our speed and all that sort of stuff, then we actually have to do a normalize, and I'd rather not do a normalize on all these things at runtime. So I'm gonna try just adding another vector to the motion and see how that works and if that's good enough. And to do that, I'm going to need to initialize my vector 4s, I believe. So this will be actual flow field data. That is a lot of vectors. Do we really have to do a bajillion normalizes, or we can somehow do this without normalization? Maybe we can do this without any of this garbage. Alright, so we can try to grab our flow field information. So it's going to be this actual flow field. We don't even have our CX and CY until after this. I mean, do we have our previous position at least? So if we have our previous X and previous Y, alright, so we need to initialize this previous X and previous Y when we create the particle. Alright, so we've got this CX and CY. So now we shouldn't have to snag absolutely everything. We'll be able to look up our px plus size times py. Alright, so we have our flow field information. So now we can apply that to our particle. So what do we want to do? I think it's going to be, we'll just add to our current position, multiply by this thing. So what we want to do is we want to convert this value to a number. It goes from 0 to 127. Oh man, what a freaking train wreck. So it's going to be like new pos.x plus equals. Oh man, these values are not even. These values are in texture space, not even in world space, so we have to convert all of them. I guess we have to pre-calculate everything. Were they already in world space? They might have been. Yeah, so we did actually convert them to world space instead of having them be in that space. Okay, so they're already in world space, which is really handy. So, since we're working in world space, it's going to be like new pos.x plus equals. How do we convert this thing? Yeah. Alright, well, I guess it's like. Well, maybe I should do some math here. If we're going to go from 0 to 127. Where the hell is my pen? I can't do math without a writing utensil. We go from 1 to 127 to 1 to 255, and we need that to go from -1 to 0 to 1. So what sort of math operation do we need to do here? We need to subtract 128, which will make us go from -127 to 0 to 127 or something like that. And then we want to divide by 127. Alright, so it's going to be like new pos.x plus equals this floater.r minus 127 divided by 127.0f. And then we're going to multiply by delta t and multiply by floater.a multiplied by m Do we actually initialize the flow field speed anywhere here? Let's just multiply this by like 1000 or something. Alright, so that should have our flow field actually affect our ripples by a certain speed. We're going to have to figure out what speed we actually want here, but we should move in the direction we're supposed to go, and then we're going to move in the direction the water is supposedly taking us, and we're not going to have any momentum. We're trying to avoid normalizing anything inside of here, because we're doing this all at runtime. Hopefully we can get away with some shenaniganry. And this right here probably needs to be divided by 255. Like that. Otherwise, because that alpha is supposed to go from 0 to 1, with 1 being the highest magnitude for our flow. Let's see, we have max wave amplitude, but do we actually use that anywhere? We'll see. We'll see if a lot of this stuff's really necessary too. Alright, so if we throw down this thing, does it move? Well, I don't see it doing anything. Well, what is our wave speed at the moment? Maybe it's just not pronounced enough, because we are seeing, like, this should be a perfect circle if nothing was happening, but it is definitely not a perfect circle. We're elongated and stretched. Let's just add like a gigantic value here. You know, just make sure it's actually doing something. Alright. So, hopefully we'll see some drastic, massive effects here going on with this position getting changed by the flow that is underneath it. And we're probably going to want to change this to a non-magical number. Look at that. Oh, that's hilarious. This shit just went off. It's just like, whoa. That is actually really cool. So, if you're not familiar with what's going on, there's a big water flow over in that direction, and it's totally sucked all of our particles over there. It looks really funny. But yeah, that's kind of what we want, is those particles to get sucked over and cause ripples and ridiculous crap to, you know, fly down and across. That is really cool. You can see the reflection of the wave that came off the rock and then came back into it over there. Yeah, all these particles are just getting sucked straight out. Yeah, we can see how how all this stuff affects each other. Well, that's what we're looking for, is, you know, real-time dynamic flow for our water. So we drop a rock in there or something, you know, boom, and all of a sudden it actually looks like it is supposed to look. And we didn't have to do any ridiculous normalization or anything else. Alright, well, I'll drop a fat sack down there and see what he looks like. After these particles clear. Gotta wait for the water to be calm. Yeah, there he goes. I mean, that's what it would look like if he's flailing around. It's moving a little bit too fast. That's true. But if he was backpedaling, that's the direction that the turbulence would be going. So we just need we need to tone it down a little bit. So we're gonna need the float here for maximum, max flow velocity? Is it this max magnitude? Yeah, looks like it. Alright, so we'll need to actually set max magnitude properly. Not bad. So yeah, that was a lot easier than I thought to get the ripples being affected by the actual flow field. And then we just have to tune the speed a little bit, and we're good to go. I think it's going to be max magnitude times like some sort of flow constant. So I'm going to throw that flow constant into the global utils real quick. This is kind of our junk drawer for global variables. And we could keep them context specific or something, but I don't know, I usually find it easier just to throw a whole bunch of... If it's a bunch of crap, just put it all in the same spot. Then you know where the trash is supposed to go. This will be dynamic, water, flow, multiplier. Mag. And let's set it to like 7,500. So it should be good to go. And I need to go resubscribe to Adam, so I can, like actually use my Amazon Prime subscription. So I can now wave hello. Gotta get those sweet bitey emotes. So today's goal is to try to get the dynamic water ripples and the water stuff going along before, of course, nuclear war breaks out and we all die in a horrible, gigantic hellfire. But that's also why I live in a basement. It's not why I live in a basement. Alright, so let's look up our blueprint to actually pass in our max speed on our initialize. It's kind of an awkward handoff having like the blueprints keep track of all this garbage. I wish just there was an easier standard way to save data for objects that are blueprinted in like the world. But I don't know. I guess that's just impossible. Max wave magnitude, how fast the water appears to flow. That is underwater. Alright, so if we play this, we should have a slightly slower... that was not slower. Well, I guess the water's just going that fast. Max magnitude is 10. Yeah, okay, so we need a much smaller multiplier. It's like some ridiculous drain. Alright, so that's this one. Basically, it needs to be an order of magnitude smaller. So just make sure this is working as intended. And then I will have to then work on the actual material itself. Yeah, and that's what we're looking for, is that the flow of the water actually goes and does stuff. What a concept. What a concept. Let's do what we normally do. Let's make sure everything works in shipping before I start working on the actual material. Let's just make sure that I have what I believe I have, doing what I believe it does. So we'll cook this thing out, see how it goes. And I am up at a reasonable time today, which is slowly going to roll around into very unreasonable times. But that's fine. So it'll just take a little bit compiling here. Gosh, so I'm going to have to think, what exactly do I want to do with the material for this thing? And I don't want to really get ahead of myself here. But I think we're at that point where I can actually get the dynamic drawing in here. What do we want it to look like? I mean, decals and the rest are going to be a separate thing. And aren't going to be part of the material, they're just going to draw on top of this thing. So that's not a big deal, but this other material stuff will actually be specific. There it goes. Yeah, it actually works. What a concept. We've got our waves that kind of come in here, cause all sorts of crazy interference. Do what waves do, you know? And we're hitting our FPS targets and everything. That's really cool. I like that. Like, that's actual dynamic water flow. What? I mean, it's statically computed, but it's still dynamic. Alright, well, I guess it's time to start working on the actual material then. So what I want to do is create a ripple. So we have a texture here that we've actually written to. So I think if we go into our water material itself. Now, as soon as I edit that blueprint, it freaks the hell out. So. So do we actually have the texture for this getting passed in? We're at 15 out of 16 texture samples for this material. So we're going to want the... What sort of effect do we want on here for this? I need an example material. I need to like be able to dump this thing out into a texture that I can then kind of play with. So let's add a button to dump out the texture. So let's make a new function here. Let's say save debug, save dynamic ripple texture. This is a public method that we can call in here, put it as debug. I need the root. So what is the root for this thing? Get asset for current level. And if you're wondering why these functions don't exist, that's because I wrote them myself for me, not for anyone else, because I'm a selfish person. So I need the texture pointer. So go ahead and save it, but I'm going to go in here and make a... I already have the texture. What am I doing? It's a dynamic texture. It's in the texture creator component. I can just call get texture. So I need to grab the... Well, it's inside of the... Gosh, everything is... Let's just close everything. Should be in setup shader variables. I think it's right here. Dynamic flow field texture creator. I don't think we're going to have a dynamic flow field. We don't need all that other crap, I don't think. I think this will be plenty of stuff for us. So I'll grab the texture, slot it in here. What is this? Return value is a texture 2D. Well, what do I have then that I can use that's not an F color? I've got update texture from render target, set target. I have saved texture asset, which takes a T-ray of F colors and all that sort of stuff. Okay, update texture regions. Load texture into color array. What do I do with the objects here for these guys when I click the button? Let me just see exactly what I was doing with these. I've got this draw material to render target, update texture from render target. I mean, it's basically like update texture from texture, or it's create texture. It's really this like save texture asset, and what I want to do is instead of taking I want to be able to take a U texture 2D pointer texture. I'll just save as texture asset. And this is just some of the stuff where I'm like, why do I have to go into C++ and build shims for all this garbage? It's like I want to save this asset as something else, but it's never a simple thing. It's always like, well, don't do that. Okay.